it's not just changing the sign here. It's you have to actually multiply in the number.
So that would be a 2x, and the signs would stay the same?
So they stay the same, yeah.
Now it'd be 2x plus 2.
And then you bring the -4 down. What can you combine at this point?
Just the 2 and the 4,
That's right.
which would be a -2, so that'd be 2x -2.
Good.
How do you know when to multiply it versus doing the distributing? Is that, do you only do the regular distributing if there's a negative sign in front of a bracket? If it's a
The-
number in front of a bracket, do you
They're
have to
they're
multiply?
both they're both distributing. The negative here, changing the signs, is kind of a shortcut or a subcase of it. You're always distributing. And you're always distributing. But let me give you another example to maybe make that more clear. Let's say it's -3 times 4x minus 1.
So would that one be multiplying?
That's right. This gets
So
multiplied.
if there is actually a number in front of it, so it's always multiplying, but when there's no sign, it's just a 1.
That's right. Oops, sorry about that. I might know why that went off. Okay, so this is -3 times -3 times 4x. That's -12x. And then -3 times -1 is +3.
What's the rule for multiplying negatives?
So if they're both negative, it becomes a positive.
If they're both opposite, or is it always negative?
Yeah, if you have one
Okay.
positive and one negative, they both become negative.
Okay.
Okay, so let's try kind of like a synthesis problem here. Let's say it's -2 times 3x minus 1 plus 4 times x plus 2. Okay, so you're gonna distribute this
Both of
negative.
them separately and then bring them
Yes,
down as I go,
yes,
basically.
exactly.
Okay. But you don't have to multiply like 1 over both of them.
No, no.
Okay. So it would be, that would be -6x
Good.
and then +2.
Yes.
And then the second one would be
There's really a 1 here.
yeah,
It's
so
not right.
and that, but there I was looking at the signs. So there's no so just be 4x.
Good.
And then 8.
Yes.
And then you would just combine that, and then you would do the
Mhm.
4x and 6x, which would be -2x.
Good.
And then 10 plus 10.
Plus 10. Good. Let's try another one here. Okay, give this one a try, please.
And then +2.
Okay,
And -6x.
good.
-12.
Okay,
And then -6x.
good.
And then altogether that would be -12x,
Okay.
right?
Yep.
And
Good.
then negative plus yeah, -10. It's
Yes.
-10.
Yes. Perfect. So you mentioned last week that the like there was something you had never gotten to yet in math. Was it factoring?
Well, factoring and like the factor tree sort of stuff, that
Okay.
always, I didn't, it's a lot, that was something that was hard when I went through it
Okay,
in the book. But the thing that I always stopped at that I never got past was the multiplying polynomials.
okay, okay. That's what it was, because that's where we're at now, is multiplying.
But it's
Polynomials
subtracting though. Did we have already done subtracting?
right here.
Oh, okay. Okay,
Yeah,
that makes sense. Never
yeah.
mind. I was thinking in terms of like distributing negative numbers.
And you've done that.
I wasn't thinking about it as a negative sign, like
Yeah.
I'm subtracting. Okay. That makes sense.
So we're gonna
But yeah, that's what I stopped at.
so we're gonna go really basic here. This is the most basic multiplying that you can do. Okay. This is, oh, did you jump out? Hello, hello. Can you hear me
Hi,
okay?
this yeah, the Zoom just like kicked me out. I don't know why.
Yeah, we'll
It
blame
might have
Zoom on
been
that. We'll
might have
blame
been
Zoom
my
on that one.
might have been my connection. Like it just dropped out of nowhere. It did
Okay.
like a bubble
All right. Well,
and
this,
gave me a little.
yeah, so this is the most basic multiplying that you can do. And we're going to use what's called the FOIL method. You probably have heard that before. So F,
Oh, this is that first inner outer last thing. Maybe
yes,
it was dividing that I stopped at, but I'd like to do some multiplying too,
of
just to
course.
make sure I'm refreshed on it.
So F means first times the first. So here is the F, X times X, which is X squared.
And then the outer ones would be the x and the 2.
Yes,
And then the inner would be the 1 and the
that's right.
x. And then the last would be the last 1 and the 2.
Yes.
When I'm okay, I did do a little bit of this because I remember I would do a little I would do the initial of each one like above or below the number to keep them in order.
Yeah. Now you don't do
And
them
then
the
I would
way,
write them out like that. But
yeah, we want to do this a little more compactly, but you do combine the outer and the inner. What is 2x plus 1x?
2x? Oh no, 3x. I was thinking of
3x. Yeah. So
multiplying.
your final answer here, let me rewrite it, because this is what we want you to, this is how we want you to present it. It's like you said, x squared plus 2x plus 1x plus 2, x squared plus 3x plus 2.
So what do you do from how do you multiply?
Just like you did. First times the first, that's the x squared. X times x is x squared. X times the x is x squared. X times the 2, x times 2 is 2x. Then the 1 times the x is 1x. And then you do the 1 times the 2, that's 2.
Oh, okay.
Okay, so just like you did, but so let's try another. Let's go x plus 3 times x plus 4.
So the first one would be just 1x.
X times x. X
Yeah,
times x. Yeah, what is
just
x times x?
just x or 1x or whatever.
X squared. It's
Oh,
got
do you
it.
add an exponent if you multiply them?
That's right. So x to the 1 times x to the 1
Is
is
that
x squared.
is that only if it's a variable like a letter?
I'm having a little bit of trouble hearing you. I'm not sure if
Oh,
something
sorry.
changed,
Is
but
that let me see if taking out
no,
my
no, now it's clear.
earbuds might help
No,
a little bit.
it was really
Is
clear.
there, I'll plug them. I can see if it reconnects.
Yeah, I can hear you great
So
now.
does that only apply to the letters?
Yes.
Okay, so that's only if you multiply the letters, it's however many there are basically, because they're each
Yes.
a 1.
Yeah.
Okay.
I mean, you're adding the exponents 1 plus 1. But
Oh,
if
so you're
that's,
adding them basically.
yes, the exponents, yes. Okay, so now we've got to do x times 4, x times 4.
Would that be 4x?
Yes,
Okay.
and then 3 times x,
And then that's just 3x.
good. And then 3 times 4.
12.
You can almost always combine the outer and the inner.
You have to do that at the end, or is that just like a shortcut sort of deal?
You do have to do this. You can wait till you don't want to try to do it in the middle of the calculation. Just do it here at the end, just one extra line. So this would be plus 7x plus 12. Is that okay?
Yeah, I'm just not sure why you combine the two middle ones.
To simplify, so the idea is it's reduced when everything is kind of in its place. These are like terms, so they
Oh, wait, so does it not matter if it's the two ones that are in the middle? Is it just combining like terms?
it's generally it's yes, to answer your question, yeah, they just happen to be in the middle, but you do combine like terms here. The O and the
Oh,
I almost
okay.
always combine though.
Okay. I thought it was like a rule that you had to combine the O and the I specifically.
You'll see that changes depending on the way the problem is presented. So let's go look at another example here. Let's do two negatives. X minus 5, x minus 2. Okay, so give this one a try, please.
So that would be the x squared,
That's right.
and then the outer would be the x and the 2, and that would be negative 2x.
Yes, very good.
Okay, and then it would be negative 5x.
Okay, and the last one?
The last one would be, let's see, negative 10.
Okay, they're both negative. Negative
Oh, wait,
5.
no, that's not adding, it's multiplying. It would be regular 10.
Yes. And then these combine here. Minus 7x plus 10.
Okay. They're also end up showing up in the middle.
Yes. So have you try another one here. Let's go x minus 3, x minus 6.
So another x squared, right, to start
That's
with?
right. That's right.
And then negative 6x.
Okay, good.
Or, yeah, outer. And then negative 3x and 12.
Try again on the last one.
Oh, no, wait, that's not a 4. No, wait.
Minus 3 times minus 6.
18.
Yes, positive 18.
And then combine the two middle ones.
That's right. What does that become?
Negative 3. No.
Try again. Try again. They're both
Just
negative.
negative 9.
Good. Questions on that?
No.
Okay. So another possibility is that one is positive and 1 is negative. Same thing though, you still FOIL, you still multiply x times x, x times -4, 5 times x, and 5 times -4. But this is the other possibility that you might see. So you want to give this one a try?
It would be the x squared
Good,
-4x,
perfect. Yep, keep going.
5x,
Okay,
and then -20.
yes, yes. Okay, so what is minus 4x plus 5x?
One.
1x, yeah. Minus 20, good, really good. Everything okay over there on your side? Seems like the energy level dropped a little bit, or?
Yeah, I'm good.
Okay, all right. So here is another possible question you might see. They sometimes put coefficients in front of the x. So it might be like 2x minus 3 times 4x plus 5, okay? And this just increases the multiplication that you might see when you're working on some problems like this.
But you don't add the exponents in. It wouldn't be like x squared. It would be like 8x, right?
8x squared, yes.
Oh, so you would add the
Yes,
exponents,
yes,
but only for multiplying, right? You don't
that's
do
right.
that in the. Okay.
So like the 2x times the 5 is going to be 10x because there's only the 1x there. What is the inner?
The inner would be -3 and 4x, which would be should be -12x.
Good.
And then you could combine the. Wait, is there another one? I forgot to do the last.
You have to
Yeah.
do the last. There's
There's
always 4 terms.
let's see, it would be -15.
Good. Combine the outer and the inner.
Would be -2.
Good. All right, very good. You're doing great. So another style of question that you'll see here is when they give you two binomials like x minus 2 times x plus 1, but then they put a number on the outside here like -3. All right. So your focus though should be on foiling first. Okay. Then you multiply everything by -3. So you can almost treat it like there's brackets here. You're going to do what's inside the big brackets first, and then multiply everything by -3.
So I would do the x. I'd start with the x, and that'd be x squared first,
Yes. So you're still going to do the x squared stuff.
and then
Give me the rest here, please.
inner, no, outer. And that would be 1x, and then inner would be -2x.
Good.
And then last would be -2.
Good. So you combine like terms.
Oh, so you combine like terms before you distribute.
Yes, that would be preferred.
Okay, so that would be the two inner ones, and that would be -1. No, yes, Yeah, negative 1x.
Okay, and then you got to
Yeah.
multiply everything by -3.
So that first one, would that be negative 3x squared? Okay.
Yep.
And then
Keep going.
is it for 2 multiplying negatives, would it make it a positive or
Yes.
no?
Yes.
Okay, so that would just be 3x.
Good.
And then that would be 6. Positive, yeah.
Yep. Perfect. Okay. Let's do a couple of standardized questions.
Okie
So
dokie.
you said last time these were almost easier because the answers are there.
Yeah.
So go ahead and try this one, please.
Is this a multiplying question?
Yes.
Okay. Would it be A?
Yes, it is A. Very good.
Okay.
All right, I've got another one here. I'm not going to put the answers in because I think they actually give it away too easily. Or I can, if you need me to, I can write answers if that's what you'd prefer. But
Oh, so it would have the exponent too. I
yes,
was about
yes,
to ask that.
yes, yes. Get these in a little tighter so you can see all of them, but see everything here. There we go. How are you doing on this one?
I'm doing okay. I'm doing the beginning part of it still. A lot of X. Oh, I don't know, because the answer I got isn't any of the ones you just wrote.
Okay, did you multiply the 2x plus 1 times the 4x plus 1?
Mm-hmm.
8x squared plus 2x plus 4x plus 1.
Yeah, that's what I started
So
with.
8x squared plus 6x plus 1. And then you have to multiply everything by the 3. So 24x squared plus 18x plus 3.
Oh, I think I just wrote it backwards. I wrote 42, but it's all the same.
All right. Well, this is a tough problem, and the answers weren't they're well disguised, but so now we need to talk a little bit about multiplying by an x. So let's say it's x squared plus 3x in parentheses, and you multiply everything by an x. And you kind of asked me this earlier. When you multiply and the bases are the same, you add the exponents. Okay, so that like the first one here, when you multiply x times x squared, you're going to add the exponents. So it becomes x cubed. Then you're going to take the x and multiply by the 3x. It just affects the x, so it's 3 times x to the 1 plus 1 power, 3x squared. Have you seen this before?
Mm-hmm.
Okay. All right. So now, let's do another example here off to the side. Let's say it's like 2x squared times x plus 4x squared. It's not only the x that you multiply, and it's also the 2. Like the whole thing multiplies inside here. Okay, so the x squared times the x becomes x cubed with the 2. And then the 2 times the 4 is 8. And then the x squared times the x squared is x to the 4th because you add the exponents. If you've seen this before, it's just an extension of what we just did. Give you a few practice problems here to try or guide me through. Any questions though on that, or?
Mm-hmm.
All right. So let's try a problem here. Let's say it's 3x times 1 plus 2x minus 4x squared. Okay, so we're going to take that 3x, go into everything here. Tell me term by term here. What is 3x times 1?
It's 3x.
Good. And then the 3x times the 2x.
6x squared.
6x squared. And then 3x times negative 4x squared. What does that become? Just do it in pieces. 3 times the negative 4. Negative 12. And then how about x times x squared?
Is there no, the negatives don't affect the exponent at all?
Nope. Nope.
Oh,
So what's the x? What's the power of x here?
3.
3. Good. Okay. All right. If you understood that, here is a test prep problem. To take a look at here. Just bring that down. Okay. So you're going to take this x to the 4th and multiply in to each of these.
maybe.
Yeah, so it's 3x to the 6th plus 9x to the 5th minus 8x to the 4th. Yeah, it is letter B. It's a lot easier when the answers are there. So here's one more that's kind of like that. I'll put that up here on the screen for you to try.
Is it D?
It is, yeah, it is D. 2x cubed minus 6x squared, letter D. You're much faster. I mean, do you visualize these or what's going on here? I mean, you're able to do these so much faster than when you have to write them out. Not sure.
It's just hard to keep the numbers in order when I write them out.
Okay. Yeah, you're doing great. Really great. All right. I'm looking for some new problems here. Looks like we'll just have to move on to like bigger multiplications. So the next thing that you might see is a binomial meaning 2 terms, times a trinomial, meaning 3 terms.
3.
Yeah. So there is no foil for this. There is no like, here's this method that always works. What you have to do is take this x, this first term, and multiply it by each of these. Excuse me. And then you take this 1 and you multiply it by each of these. And then you combine everything. So I'll show you that here. Start with the x. X times x squared is x cubed. X times minus 3x is minus 3x squared. X times 2 is positive 2x. Is it okay how I got those?
Mhm.
So now you take the 1 and you multiply by each of these. Now there's a question of where to put the terms. The first one is 1x squared. I'm going to put that underneath the other x squared because it lines up, because we're going to add these up together. It lines up. 1 times the minus 3x is minus 3x. I'm going to put it underneath the 2x. 1 times positive 2. Put that off to the side here. So you're adding these up. And notice how they're already kind of in the like terms. So this becomes x cubed minus 2x squared minus 1x plus 2, like that. So the biggest thing is just keeping track of everything. So a lot of students do this is they put them all in one line. I don't like this, but if you do it, it will work. I just think it's harder to combine like terms. So that's why I line them up. But it's totally up to you how you do this. Let's have you try one here. Let's say it's x plus 2 times minus x squared plus 3x minus 4. Again, you just multiply everything on the top. Can you give me those multiplication results, please?
How would I multiply a positive x by negative x?
So there, think of it as -1 times 1.
Would it just be the same with the ones?
Yes.
Okay. Would
So
that be, I can't tell if it would be a positive or negative. It would be negative.
it's negative. Yeah, it's positive times a negative.
And then cubed.
Yes,
And
because
then,
the x times the x squared.
and
Trying to think of
then,
all the little wrinkles you might see here. So x times the 3x.
and 3x squared.
Good.
And then negative 4x.
Yes. So now we're going to do the 2 times everything, 2 times the negative x squared, 2 times the 3x, and 2 times the negative 4.
Negative 2 squared.
Good. Positive 6x.
And then, yeah, and then a negative 8.
Yes. Okay, so you just add vertically. You combine the ones that match. There's nothing that matches the x cubed. What goes next? 3x squared minus 2x squared. What does that become?
One x.
Good. Keep going. Minus 4x plus 6x.
2x.
Okay.
Do we make it squared?
Nope. They're like
Okay.
terms.
And then just 8 because it's by itself.
So it's just that number comes down. Yes.
And then that's as much as you can.
There's nothing else to combine. You're totally done. Okay. So we've done adding, subtracting, and multiplying polynomials. So we're basically ready to do division. We can probably hit that next time. I'm sort of concerned that your class is moving so slow. You said they're still
Yeah,
doing fractions.
yeah,